Here's something most people don't think about. A huge part of the internet runs on software that no single company owns. Not Amazon, not Google, not Microsoft. Not one CEO sitting in a boardroom deciding what happens next. It's engineers, thousands of them, working across companies, countries, and time zones. Some work at Google, some work at Red Hat, some work at AWS, some work at companies you've never heard of, and they're all contributing to the same foundations. Linux, Kubernetes, containers, monitoring tools, automation tools. No single company controls all of it. No quarterly earnings call decides whether it survives. No vendor can simply shut it down because the business model changed. And somehow, this messy, distributed, global collaboration has produced some of the most reliable infrastructure on Earth. This is the story of how open source became the foundation of modern infrastructure. Why it works. Why it can be more resilient than closed systems. And why the future of reliable infrastructure depends on people building together. Welcome to the Breakdown Economy. I'm Tony. This season, we've been talking about what actually makes infrastructure resilient. Multi-cloud, chaos engineering, distributed databases, self-healing systems, infrastructure as code, maintenance excellence. But underneath almost all of that is something we don't talk about enough. Open source. And not open source as a hobby project. Not open source as free software someone made in their spare time. I mean open source as the foundation of modern computing. Most infrastructure today depends on open source in some way. Linux, Kubernetes, Docker, Terraform, Prometheus, NGINX, PostgreSQL. If you use the cloud, you use open source. If you run containers, you use open source. If your company automates infrastructure, monitors systems, or deploys applications at scale, open source is probably somewhere in the stack. That's the shift. Open source is no longer the alternative. It is the default foundation. The traditional software model looks like this. A company writes the software. The source code stays private. Customers buy licenses. Users trust the vendor because they have no real way to inspect what's happening underneath. That model can work. It gives one company clear control. It gives customers a support contract. It gives the vendor a business model. But there are trade-offs. You can get locked in. You may not be able to modify the system for your own needs. You may not be able to audit the code. And if the vendor changes direction, raises prices, gets acquired, or disappears, you may be stuck. Open source flips that model. The source code is public. Anyone can read it. Anyone can suggest changes. Anyone can inspect how it works. And if the project goes in a direction you don't like, you can fork it and build from there. That doesn't mean open source is perfect. It can be messy. It can be political. It can be underfunded. And some projects depend too heavily on a small group of maintainers. But the core idea is powerful. Trust is earned through transparency, not demanded through control. That one idea changed infrastructure. The clearest example is Linux. Linux started in 1991 as a project by Linus Torvalds, then a college student. It was a Unix-like operating system kernel shared publicly with an invitation for others to contribute. That sounds small. But over time, it became one of the most important pieces of software ever created. Today, Linux is everywhere. It runs cloud servers. It runs web servers. It powers Android devices. It shows up in routers, cars, appliances, embedded systems, and supercomputers. And that happened for a simple reason. It was useful. It was flexible. And it kept improving. Linux is not maintained by one person anymore. It's maintained by a global community. Engineers from Intel contribute. Red Hat contributes. Google contributes. Amazon contributes. Microsoft contributes. And here's what makes that interesting. These companies compete with each other. but they also share a common interest in making the foundation stronger. That's the open source bargain. A company contributes because it helps their infrastructure, but once the improvement is merged, everyone benefits. That creates a flywheel. More users lead to more testing. More testing finds more bugs. More bugs get fixed. More fixes make the system stronger. And over time, the infrastructure becomes battle-tested in environments no single company could recreate by itself. There's also the security argument. A common myth is that open source is less secure because attackers can see the code, but defenders can see it too. Security researchers can audit it. Engineers can inspect it. Companies can verify what the system is doing instead of just trusting a vendor's promise. That doesn't mean open source is automatically secure. Bad code can be open source. Abandoned projects can be dangerous. Dependencies can create supply chain risk. But with a healthy project, transparency creates accountability. If something is wrong, people can find it. If something needs to be fixed, the fix can be reviewed publicly. And if an organization needs to validate the system, it can inspect the code itself. That matters for critical infrastructure. Because in critical systems, trust us is not as strong as verify it yourself. Another reason Linux won is its flexibility. Linux is not one single product locked into one vendor's roadmap. There are distributions for different needs. Ubuntu, Debian, Red Hat Enterprise Linux, Alpine, SUSE, and many more. Some are optimized for enterprise support. Some are lightweight. Some are built for containers. Some are built for embedded devices. That flexibility is why Linux became the common language of infrastructure. You can run it in a data center. You can run it in the cloud. You can run it on a tiny device. You can tune it, audit it, modify it, and build around it. That is very hard to beat. Linux gives modern infrastructure a foundation. But once applications became more distributed, companies needed something else. They needed a way to manage thousands of containers across fleets of machines. That's where Kubernetes comes in. Containers package an application with what it needs to run. That makes applications more portable, more consistent, easier to deploy. But one container is simple. Thousands of containers? Across hundreds or thousands of servers? That becomes a coordination problem. You need to answer questions like, where should this container run? What happens if it crashes? What happens if the server fails? How does traffic get routed? How do we scale during demand spikes? How do we deploy updates without taking everything offline? That is what Kubernetes helps solve. With Kubernetes, you describe the desired state. You tell it, I want this application running. I want this many copies. I want traffic balanced across them. I want failed containers replaced. I want updates rolled out safely. Then Kubernetes works to keep reality aligned with that desired state. That idea is huge because it moves infrastructure from manual reaction to automated correction. Container crashes, Kubernetes restarts it. Server fails, Kubernetes reschedules workloads somewhere else. Demand increases, Kubernetes can scale services up. A deployment goes wrong. Rollbacks become more manageable. That is self-healing infrastructure in practice, not magic, not perfect, but a major step toward systems that can recover without a human having to touch every failure. And because Kubernetes is open source, it created an ecosystem. Prometheus for monitoring, Helm for packaging, Argo CD for GitOps, Istio and other service mesh tools for traffic control. Different teams can build tools around the same foundation. That's the power of an open platform. One project becomes the base layer. Then thousands of other solutions can form around it. And because the foundation is open, companies are not forced to wait for one vendor to decide what matters. So why does open source infrastructure work so well? I think there are a few big reasons. First, distributed maintenance. A closed proprietary system depends heavily on the company that owns it. If that company cuts funding, changes priorities, gets acquired, or loses key staff, the product can decline. Open source is different. If one contributor leaves, others can continue. If one company shifts direction, another company can step in. If the community disagrees, the project can fork. That can be messy. But it also means the code does not disappear just because one business decision changed. Second, quality through review. In healthy open source projects, changes are not simply thrown into production because one person felt like it. There are pull requests, reviews, testing, maintainer approval, public discussion. Every serious project has standards, and because the process is visible, decisions can be challenged. That kind of peer review is one reason open source can produce very high-quality infrastructure. Not because it is perfect, because the process forces problems into the open. Third, portability. This connects directly to multi-cloud. If your infrastructure depends entirely on one vendor's proprietary tools, moving is hard. But if you build on Linux, Kubernetes, Terraform, containers, and open standards, you have more options. You can run workloads in one cloud. You can move some workloads to another. You can run some on-premises. You can design for flexibility. That doesn't mean migration is easy. It never is. But open source gives you leverage. It gives you fewer handcuffs. Fourth, cost. Open source is not free in the sense that it requires no effort. You still need skilled people. You still need support. You still need governance. You still need security. But you are not paying licensing fees just because you added more servers. That changes the economics. Small companies can use tools that look a lot like what large enterprises use. Startups can build on the same foundations as major cloud providers. That democratizes infrastructure, and that matters. Now, this is where we need to be honest. Open source is not automatically reliable. It is not automatically secure, and it is not automatically sustainable. Some open source projects are maintained by a tiny number of people. Sometimes one person is holding together software used by thousands of companies. That is not resilience. That is hidden fragility. And we've seen what happens when the world depends on software that very few people are actually supporting. A small library can become a critical dependency. A maintainer can burn out. A vulnerability can spread through a dependency chain. A malicious package can enter the supply chain. So, the lesson is not: open source is good, proprietary bad. That's too simple. The real lesson is: open source works when the community, the funding, the governance, and the maintenance model are strong. Infrastructure does not become resilient just because the code is public. It becomes resilient when people take responsibility for it. That means funding maintainers, contributing patches, improving documentation, reviewing dependencies, supporting foundations, and treating open source as infrastructure, not as free labor. Because that's the uncomfortable truth. Many companies depend on open source, but not enough companies invest back into the projects they depend on. And in the long term, that is a risk. When you look back at this season, open source shows up everywhere. Multi-cloud depends on portability. Chaos engineering depends on shared tools and practices. Distributed systems depend on common protocols and open research. Self-healing infrastructure often depends on Kubernetes. Infrastructure as code depends on reusable automation. Maintenance excellence depends on systems that people can inspect, understand, and improve. Open source is not just a software model. It is a resilience model. It spreads knowledge. It distributes ownership. It creates transparency. It reduces lock-in. And when done right, it gives infrastructure a stronger foundation than any one vendor could provide alone. But only if we support it. Only if we maintain it. Only if we stop treating it like something that magically appears for free. Open source infrastructure works because people build what they need, share what they improve, and keep the foundation moving forward. That's not a perfect system, but it is a powerful one. Some of the most important infrastructure on Earth is maintained by people you will never meet. People working across time zones, across companies, across languages, across incentives. And yet the result is something we all depend on. Linux, Kubernetes, containers, monitoring, automation. The invisible foundation underneath modern infrastructure. Next episode, we move from technology to rules, effective regulation. Because infrastructure is too important to be left entirely to market forces. But bad regulation can create paperwork instead of resilience. So the question is, how do we regulate infrastructure in a way that actually makes systems better? That's next week on The Breakdown Economy. I'm Tony. And remember, reliable infrastructure is not built by one company, one product, or one genius. It is built by people who care enough to keep improving the systems everyone else depends on. That's the power of open source.